Hi everybody, we're going to take a look at guided notes for standard 13 vertical angles, and we're going to be looking at vertical angles in two different ways, or we're going to be proving them inductively and then deductively. So this word inductive we will be defining, but this just means we're going to be using observation. So our directions tell us to draw a pair of intersecting lines. So you're going to need to pull out the protractor that you were given for geometry. And in order to draw our intersecting lines, we need to use the straight ruler edge of our protractor. You can draw your intersecting lines however you like. So I'm just going to do something like this. I'm drawing two lines that intersect. Yours does not need to look like mine. So draw any two intersecting lines. Again, yours does not need to be just like mine. And then you're going to need to measure each angle to the nearest degree. So you have 4 angles here that you need to measure. And so you're going to have to use your protractor, line up your protractor to measure the 4 angles. So on mine here, let's see if we're measuring this smaller acute angle here, the angle that I have right here. Oh, wow. Looks like mine is exactly 50 degrees. So I'm measuring this angle right here. I can put a tick mark. If that's the angle that I'm measuring, I'm lining it up and it looks like it's exactly 50 degrees. Keep in mind, we talked about how your ray is going to touch 2 numbers on the protractor, and you need to use some critical thinking skills here. If my angle is opening this way and it's starting here at 0 degrees, I'd be going from 0 to 10 to 20, 30, 40, 50. That's one way to think of it. Or another way is looking at the 2 numbers, they're 50 degrees and 130 degrees. And this angle that I'm looking at is definitely an acute angle. It's definitely smaller than 90. So I know that this angle has to be a 50-degree angle, not the 130-degree angle. So you're probably not going to get 50 degrees for your first angle. That's okay. You're going to use your protractor to measure all 4 angles. So at this time, go ahead, pause the video and see what 4 angle measures you come up with. So here were the 4 angle measures that I came up with, and you should have noticed a pattern here where you had 2 angles that were across from each other that were the same exact angle measure. So I had 2 angles here, I made 1 tick mark, and they were both 50 degrees, they were congruent. And then I had my other 2 angles, I put 2 tick marks for these 2, and these were also congruent, they were both 130 degrees. So you should have noticed that the angles that were opposite or across from each other had the same angle measure. The reason that happens is because those are the vertical angles. So my 2 angles that were 50 degrees, they are vertical angles. And my 2 angles that were 130 degrees, they are vertical angles. So because we drew our pair of intersecting lines and measured them, now we can use observation to note some things that must be true about vertical angles. So I'm just going to make a few bullets to talk about vertical angles. So we mentioned that the vertical angles are the angles that are opposite one another. Opposite one another. They also share a vertex. Keep in mind our vertex here is in the middle. This is the point where our 2 lines are intersecting, and they do share that vertex. Another important thing to note, we put the congruent tick marks on, or at least I did, and if you haven't already, I would definitely add your congruent tick marks to show which angles are congruent, and vertical angles are indeed congruent. So here we were able to draw a diagram and then use observation to come up with some things that must be true about vertical angles. Now we can define the vertical angles theorem, and the vertical angles theorem tells us that if 2 angles form a pair of vertical angles, then they have to be congruent. If 2 angles form a pair of vertical angles, then they are congruent. And we showed that in our diagram by putting congruent tick marks on the angles that are vertical. Inductive reasoning, and I mentioned this word, so up at the top, this is where we, this first proof, this was inductive reasoning. So I'm drawing an arrow from our inductive proof to this definition, inductive reasoning. This is just reasoning based on observation. Reasoning based on observation. Compared to deductive reasoning, and that's what we're going to do next. Beneath here, we're going to do a deductive proof. Well, deductive reasoning, and we actually mentioned this already, deductive reasoning is reasoning based on fact and logic. Reasoning based on fact and logic. So we already proved vertical angles based off of observation. Now we're going to be a little bit more formal, and we're going to use fact and logic in a formal 2-column proof format. So we just worked on some proofs, and we can see we have our 2-column setup, a column with statements and a column with reasons, and we are given that angle 1 and angle 2 are vertical angles, and we are asked to prove that angle 1 is congruent to angle 2. We also have this figure over here, so we're going to need to rely on this figure because we are not given very much information. When we just worked on proofs, we learned that the first thing you can always do to start filling in your 2-column proofs are to list what's given. So we are given that angle 1 and angle 2 are vertical angles. So I'm going to start off by writing that. Angle 1 and angle 2 are vertical angles, and my reason is simply that it's given. Angle 1 and angle 2 are vertical angles, given. At the very bottom of our proof, we know we're trying to be mentioning that angle 1 is congruent to angle 2, but we need to figure out the steps in between. If I look at my diagram over here, this figure doesn't have any angle measures on it. It simply has 4 different angles labeled for us. And so we need to use what we know about the fact that we've got 2 intersecting lines here. They are meeting at a vertex in the middle, or an intersection point in the middle, and we've got 4 angles. That's about all that we're given there. I see something right away that I notice that I could say. I could say that when angles here form a line, like for example, angles 1 and 4 here are forming a straight line, I know what they're going to add up to. We've already learned about this. These would be supplementary angles right here, angles 1 and 4, because they form a straight line. They form a line. So I'm going to write that. I'm going to say that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. And these are the 2 angles that I just underlined in pink. And the reason for that, we can say linear pair property. The reason I'm going to say linear pair property and not supplementary angles is because we're getting it from a figure. I'll abbreviate property there. We're getting it from a figure. So we see a line and we see that these are a linear pair, meaning they form a line. So by definition, that's what them adding to 180 degrees means when they form a line like this, linear pair property. I see that I have 2 other angles here, we could say, that form a line. If I look at it this way, I have angle 4 and angle 2 that also form a line. So I could similarly say the measure of angle 4 plus the measure of angle 2 equals 180 degrees. Measure of angle 4 plus the measure of angle 2 equals 180 degrees. And again, the reason is linear pair property. So I took that from the figure. Now, is there something that I could do now that I've listed both of these statements having to do with the linear pair property? I said that this stuff here, these two angles that I underline in pink, is equal to 180 degrees. And then I also have this stuff here, or these two angles underlined in yellow, equal to 180 degrees. And we did this kind of stuff in algebra all the time, and it was actually called substitution. If you have two things here equal to 180 degrees, we can just substitute them. So one way of saying that, if pink is equal to 180 and yellow is equal to 180, then pink must be equal to yellow. So I can say the measure of angle 1 plus the measure of angle 4 is equal to the measure of angle 4 plus the measure of angle 2. So what I did there was set the two different parts equal. And that is called the substitution property. Substitution property, which we use a lot in geometry. At the very end, I need to say something about angle 1 being congruent to angle 2, or that the measure of angle 1 is equal to the measure of angle 2. So I'm close. If I look at this statement, the only thing that's in the way is this angle 4. Like, I'd like to be able to get rid of this angle 4. Is there a way that we can just get rid of this angle 4 from the problem? Well, there is, because the measure of angle 4 exists on both sides of the equal sign. So because it is an equation, it has to stay balanced. But I could simply subtract the measure of angle 4 from each side by doing the subtraction property. And by subtracting the measure of angle 4 from both sides, I'll be left with the measure of angle 1 being equal to the measure of angle 2. And that's essentially what we were trying to prove. Here we're using measures to talk about their specific angle measures. What it wanted us to prove is that they're congruent. So we could also write it this way. Angle 1 is congruent to angle 2. And this right here is called definition of congruence. So in one way, we're using lowercase m's and an equal sign to talk about their exact angle measure. And in the other way, we're using a congruent sign. We drop the lowercase m's, and here we're talking about congruency. So here is a very formal deductive way to prove that vertical angles are indeed congruent. That's what we were trying to prove here, and we did that by using a two-column proof setup. All right, so now we're jumping to the back side. Now that we have talked about what vertical angles are, what they look like, now let's do some more work with vertical angles. So our directions tell us to list all of the pairs of vertical angles, and we do not need to combine the angles. So we said that vertical angles are angles that appear across or opposite one another. So for example, right here, I have this angle, and the angle that must be opposite it would be right here. One thing I often tell students to do is with your pencil, you can draw a dashed line to find the angle that is opposite of it. So in this case, I used one tick mark and one tick mark to point out those two vertical angles, and I need to list them. So I can't just say angle M is congruent to angle M, because really every angle in this figure is angle M, because M is our vertex. So this is an instance where we need to use 3 letters. So if I'm trying to title this angle, I could call it VMQ, or I could call it QMV, but again, I have to use 3 letters, and M has to be in the middle because M is my vertex. So I'm going to call it angle VMQ, and the angle that it would be vertical to would be angle, let's say, SMT. These were the ones that I used one tick mark for and highlighted them in pink. Now let's pick a different pair of vertical angles. So I'll use 2 tick marks now. So angles that would be opposite one another. So here and here. And we need to use 3 letters to talk about them. So angle VMU and angle, let's say RMS. Notice I'm using capital letters. When we title angles, we're using 3 letters and they must all be capital. And then I have one last pair. I'll use 3 tick marks for these ones. 1, 2, 3. So my last pair of vertical angles here, I can say angle UMT. And the angle opposite of it would be angle QMR. Keep in mind, like I mentioned, you can switch the first and the last letter. So this could have instead been TMU. That would be fine, but M has to be in the middle because M is your vertex. Again, if you're trying to find the angle that is opposite it, sometimes it is helpful to put tick marks on the angles or to make a dash line going through your figure. If you're doing it with pencil, you could make your dash line, then erase your dash line when you go to list your next pair of vertical angles. Come up with a method for you so that you can be nice and organized and make sure you don't miss any pairs of vertical angles. All right, example A says to find the values of X and Y. So right away, I see that I have a 130-degree angle here, and angle X is opposite it. Angle X is actually its vertical angle. So we learned that vertical angles must be congruent, hence me putting 1 congruent tick mark on them. So by default here, by definition of vertical angles, X has to be 135 degrees also. So I'll say X equals 135 degrees. So that just leaves us with finding Y. So we need to figure out what Y equals. And I can see right here that 135 degrees and this angle Y form a straight line, or these two angles here form a straight line. They're a linear pair. They must add to 180 degrees. So if I know this angle that I put 1 tick mark, if this angle is 135 degrees and I'm trying to find the measure of angle Y, I can do 180 degrees for the straight line minus 135, and then that will give me what the measure of angle Y is. So again, I can do 180 minus 135. So then I'll get that Y equals 45 degrees. In example B, now we don't just have a degree measure, now we're asked to solve for X and we have expressions. I can see that my 2 expressions are on opposite vertical angles, and we know that vertical angles are congruent. So based on that definition, we can make a note here that these must be equal. Must be equal. So I can simply set these 2 expressions equal to each other. So I can say 2x plus 28 equals 5x plus 19. 2x plus 28 equals 5x plus 19. And there's our equation that we need to solve. So we need to move x's to the same side. I would probably do minus 2x minus 2x. So I would have 28 equals 3x plus 19. So I moved my x's to the right. I need to now move my constants to the same side. So I need to move this positive 19 to the other side so I can subtract 19 on both sides. And I'm left with 9 equals 3x. My last step here to get x by itself would be to divide by 3. And my final answer, 9 divided by 3, gives me 3. So it just wanted me to solve for x. So my final answer here is that x equals 3. We can definitely check this by plugging in x equals 3 into both of our expressions, and we better get the same thing. So what I mean by that, plug x equals 3 into this expression, and you're doing 2 times 3 is 6. 6 plus 28, I get 34 degrees. Let's test the opposite vertical angle, and this one also has to be 34 degrees. So when I plug in 3, 5 times 3 is 15. 15 plus 19 gives me 34 degrees. So it worked out that these two have the same angle measure, which has to be true if they are vertical angles. So if for some reason you get an X value and you go to plug it back into your two expressions and you don't get the same angle measure, that means that you found the wrong X value. All right, at this time, go ahead, pause the video and see what you come up with for you tries 1 and 2. Let's see how you did. So for you try 1, I got that Y is 101 degrees and X is 79 degrees. And for you try 2, I set my two expressions equal because they are vertical angles. I ended up with X equals 5. And to double check that X equals 5 was correct, I plugged it back into my two expressions and I ended up getting that both of these vertical angles were 35 degrees. Last part of our notes is a formal 2-column proof here. And you'll notice that all of the statements are already filled in for you. So we are given that angle 1 is congruent to angle 3, angle 1 and angle 2 are supplementary, and angle 3 and angle 4 are also supplementary. And at the very end, we have to prove angle 2 is congruent to angle 4. We also have these figures here. Notice they're two separate figures here. We have one here for angles 1 and 2 and one here for angles 3 and 4. We've got our statements filled in for us, and so let's start by looking there. So our very first statement says that angle 1 is congruent to angle 3, and that was given to us. You'll notice that just like on the front side of today's notes, we are writing it both ways, and again, this is called definition of congruence, and basically we can write it with them being congruent with no m, or we can use the lowercase m because we're talking about their specific measure being equal. So these are very similar, but the notation does matter. So the reason we can switch between them is because of the definition of congruence. Next up, I see that the measure of angle 1 and the measure of angle 2 adds to 180, and the measure of angle 3 and the measure of angle 4 also adds to 180. And the givens told us that they were supplementary. So because we know that the definition of supplementary means that they add to 180, we can say that this was the definition of supplementary angles, and I'm going to abbreviate here, definition of supplementary angles. Next up, I see things being equal to 180 degrees dropped out of my proof, and now it looks like I'm actually setting that the measure of angle 1 plus the measure of angle 2 right here is equal to the measure of angle 3 plus the measure of angle 4. So this is very similar to what happened on the front side of our notes, where here I had what I was saying on the front side, pink is equal to 180, yellow is equal to 180. So now I can just set them equal to each other because of the substitution property. Substitution property. In my next step, I need to look and find what is different about this step because they look very similar. And if you look closely, the only thing that is different is right here. And I boxed it for you. We replaced the measure of angle 3 with the measure of angle 1. Why were we able to do that? Why could we replace measure of angle 3 with the measure of angle 1? Well, at the very beginning up here, we said that the measure of angle 3 is equal to the measure of angle 1. So because we've already specified they're equal, that means that we can replace them. So this is, again, substitution property. Substitution prop. And we're almost done. So here, what is happening? Well, we can see we do have the definition of congruence piece again, where we're switching between talking about their angle measures to talking about them being congruent. So we need to notice what is happening in this step. And I'm noticing that the measure of angle 1 has dropped out of the proof. So we no longer have the measure of angle 1 in our proof. And the reason for that is we subtracted it out of our proof. The measure of angle 1 existed on both sides, and because we're keeping our equation balanced, we could subtract the measure of angle 1 from both sides, and then it will no longer be in our proof. So this last reason was the subtraction property, because I subtracted the measure of angle 1. And then I'm left with when I'm asked to prove that the measure of angle 2 is equal to the measure of angle 4. And again, this is us just switching back and forth because of the definition of congruence. So you see it written both ways. Well, what did this proof prove? What exactly was the point here? Well, our point here was we were looking at angles that were supplementary to each other. And what does that mean? Because here we are looking at 1 and 2 are supplementary, 3 and 4 are supplementary, and it's something called the congruent supplements theorem. So what this says is that if two angles are supplements, of congruent angles, if two angles are supplements of congruent angles, then the two angles are congruent. Then the two angles are congruent. In this case, in our proof, if measure of angle 2 and measure of angle 4 were each supplements of two congruent angles, and our two congruent angles were angles 1 and 3. So if you look up at our figures, angles 1 and 3 were congruent. So angles 2 and 4 were supplements to those congruent angles. So then that means that those two angles, 2 and 4, we proved have to be congruent. Thanks for watching.